talks I attended, what I should be focusing on, who are the people I met and all. So this is just a brief. That's my daughter there. She was one of the speakers. So last day, the only thing she was looking after was I need a puppy, sort of a thing. So and then there was an interesting thing. So Microsoft announced that they were going to do an Azure Linux thing, which when I talk to people who have been there for a long time, they still remember the fact that around the early 2000 and all, Steve Ballmer called Linux a cancer. There was the famous Halloween paper documents that came around that we need to kill Linux. And today, 30 years later, they are actually being full flow. And when I was talking to people in Microsoft, some of the guys, they essentially accepted the fact that it was Satya Nadella who actually done all this thing. He realized that the value of open source comes from not fighting it, but being co-opting it. So, and this is what our CDCon, we had a CDCon thing, I'll come to that later. This is some of the people there. This is Brett Smith, he's a distinguished engineer at SAS, looks at SBOMs and basically a lot of the work that we need to do in provenance testing, software build management, these are the sort of things we will say. This is Minimus, it's one of those companies that is making, selling container images, slimmed down with minimal CVs. They say we test it out and do it. Interestingly, there were two companies there. One was Minimus and the other was ChainGuard. ChainGuard guys said that we have a lot of free images that you can use. Minimus guys told me initially that we don't have anything free. You have to come subscribe to us. But 2 weeks later, they sent out a message that they've joined something called Project Athena. And yesterday, I think I got an email from them saying that there are now free images available. So that's an interesting perspective that I'm just pointing out that that's how possibly things have changed. I do not know what led them to do it, but what I would really like to say, these are the few things that are there. One is the base image, as I said, the decision. These are some of the things that I believe that architects should be able to understand the system so that the biggest problem we would have is if you design a system today is a lot of the technical debt that goes in. We need to be able to fix it, avoid it, and as we all know, we want to shift left because the more we have accumulated stuff over the years, the more painful it becomes to be able to fix it, right? We have all these broken systems, we are still running COBOL systems, mainframes, and stuff like that. So these are the few things that I talked about. And so this is about me. I've been using Linux since 1995. I think it was 1.x or something. It was a Slackware system. I started off because my college, we were trying to get internet working. That time was 1994, 95. IIT Kanpur was an ERNet backbone, and we used to have a 36 kbps or 14.4 kbps dial-up modem, which would dial up into IIT Kanpur. And I don't know how familiar you guys are with the telecom tariff those days, but it used to be, Kanpur would be 3 seconds of pulse rate in full rate. So we would pay 20 rupees a minute if you were doing the daytime. If it was nighttime, it was 1/3, so it would come down to, so it would be 10 rupees a minute. And those 10 rupees were not today's 10 rupees, right? So those 10 rupees a minute means that every time you dial into IIT Kanpur to get our mail, it would be incur the college a bill of around 1,000 or something like that. And I was one of those people who had friends in the US. So one of my friends sent me an email, and there used to be this thing called FTP mail. FTP mail used to be a project where you could, because you don't have a direct connection, you could actually send an email to one FTP server that please send me this particular file via mail. So it would take that file, chunk it up into mine using base 64 encoding and send it down to you. So that was one way you could actually get software. So the reason I did that was the message that my friend sent me said something, this is a MIME encoded message, and MIME mailers are Pine. If anybody has heard of PINE, Pine. Pine is not L, is the acronym of it. It's a, before the mail reader in those days, it's a graphical It's a text-based reader which works on DOS, Linux, largely, but we used it on DOS. ELM was another version. It was a University of Washington project, I think. So it said that to be able to read these MIME encoded messages, you need a reader-like pipe. So I said, okay, fine. I used FTP made. For 3 days, the system was stuck there because the file was so large, it couldn't come down. Then the professor called me and gave me a backing. Well, there were reasons why he didn't say too much to me, but that's a different story. So then they called up IIT Kanpur, deleted that particular mail, and so that was the way life was. Then we got a 9.6 kbps VSAT link. And over that VSAT link, we were getting full internet, but we don't know how to get it accessed. So I'm digressing a bit on the topic, but just this history seems to be interesting enough. We're trying to use a Sun OS system, it wasn't working. Then I read in PC Quest magazine, I think that there's this Finnish guy who's written something called Linux. And I went to Delhi, I found a book on Linux, I got me the CD. My brother had given me a computer in those days, a 486. So I said, let me try it out. I tried it out, I learned it, then I went to the professor and said, let's try this out. He said, fine, let's. And that is how it got into setting up the whole internet server, getting in touch with all the Linux users around the world, in India, the island group and all of that. So then I have a PhD in technology and public policy, which was also because of my interest in open source and my look around the industry, why we are not innovation. So that's what I wanted to really look at. So that's what my thing is. So what I really learned is that these are the interesting things, and this is one of those things that I've seen the whole idea of there are so many moving parts into these systems, and not all of them are owned by me. We actually even don't own so that, and that becomes a very important thing that if anything in the system breaks, our whole edifice can come falling down. You've got a kernel that, and I do not know how many of you have been following it, but the Linux kernel frequency of releases has actually increased a lot in the recent past. I'm planning to do an empirical study on that, why, what and all. And even in the open source India event that happened a few days ago, couple of weeks ago, there was a Linux World video, it was a keynote, and he's also saying that the Linux kernel is actually, I'm being too much, every time I do it, yeah? No. So, I do a release, and here also due to the fact that there are pretty many releases happening. Then there are container runtimes, you all know. Then the orchestrator, their packet registries. Packet registries was an interesting talk on the third day of the keynote, saying the problems that we are having whenever we do an npm pull and things like that, how much it impacts the backend infrastructure. Because we're talking, every guy when you do an npm pull or whatever it is, I don't know, what is an npm command? When you know package manager. So whenever you do an npm and get some new packages, every time it actually impacts those backend servers a lot, every time. So those are things that possibly we should be looking at, how now local caching and all that sort of stuff. So this was an interesting talk that this person said that the kernel scheduler also is becoming an important aspect, which is something that I didn't realize. And supply chain regulation, EU has this called CRA. I forget the full form of it. It basically is a regulatory angle where you say you have to actually define everything that goes into your system, and that is a challenge that a lot of the embedded folks are actually feeling. People at Qualcomm, for example, they make the IC for all the vehicles. So if your vehicle IC, the entire firmware, everything has to be certified, and that basically adds a lot of process. So this is what it is. So one is the base image. So we know this thing. There are lots of CVEs that happen, and one of the biggest challenges whenever you do a pull or docker from Ubuntu, all that is that you get 600 MB just for doing nothing. Right? I think it's 150 or 200 MB. I don't know. I personally prefer Alpine. But that's so, and the whole idea has become that you need to do slim down images. So you need to do these things that, so that is what these people are selling. They say that we take this image, we look at all the CPEs, we evaluate them regularly, we try to mitigate them, we try to fix it, and we try to build that. Then another angle that I saw in Minimus was something that I hadn't seen earlier, that they also provide one container which you can only use for static threads. Which is actually, if you really think about it, going back 30 years and thinking about the evolution of static versus dynamic linking and things like that, I realized that what Go has done is actually a pretty interesting thing, especially from it comes from the perspective of security and all of those sort of things, where you ensure that everything is self-contained in the binary. And you just need to change the binary, you don't have to worry about other dependencies. But then there are other things that software does that requires dynamic linking, and this is the Azure Linux announcement that they put up. So the interesting thing is that they have said that now they are also owning these things. And this is where, and this is another interesting thing if you look at the industry trend per se, that the hyperscalers are actually trying to own everything from silicon all to the app. There was a time when we were talking about core competencies, where you did one thing which you were good at and you didn't do the rest of the thing. Possibly Apple showed us that the greatest value comes in owning the entire stack, being vertically integrated, which also has its pitfalls. So these are angles that are there. So now they have their silicon, they will have their own base images, they will pay Linux people to do this work on all of this. So the idea is that now instead of just doing from X, Y, Z, I think it becomes that we should need to specifically say what sort of an image we need to be using. And these are rules that people have to justify why they did it. Just because it's available, just because the Web 2 latest is available, doesn't mean that you really need to use it. We need to be able to be cognizant of the fact that these systems will be in production for a long time. Every time there is a critical or even a non-critical vulnerability, the problem happens is that even if you do not have a pathway to reach the vulnerability, still it will be flagged as a CV and you will actually have to respond to 20 different people saying that your software is a flaw. That was one of the projects that my daughter worked on last year at Visa, where she said that we're building an SBOM sort of tooling where we've tried to understand that what are the fixes that are critical and the others are just noise. But that is good enough for an engineer's perspective. We can say, okay, this is noise, we don't need to fix it, but when it has to go to something like CRA or something where the vulnerabilities will be scanned, nobody is going to worry about the fact that does your code even read that path. But the problem is that minimal images lack all the debugs, they don't have all that, the rest of the stuff, they don't have package managers, and also we need to have something, tied in something which basically means that we will need to consciously write our code in this manner that it can hook into all the stuff so that at runtime we may be able to debug it. Then provenance, this is a big thing, as I said, that provenance has been a huge problem in the open source world, we all know that. And with the coming of AI and all those sort of things, it's also, and then if you remember 2 years ago, I think it was been 2 years, we had the libexit vulnerability. Anybody here remember that? libexit, XZ, the compression algorithm.
Yeah, in the open source library.
Right. What was it?
I think someone infiltrated, spent years trying to get in, and once the author was like tired of it, he gave the access to him, and then he pushed a vulnerability that would scan all the things in the
Yes.
And I think when Microsoft researchers saw that it was running more CPU cycles than required, and then he
got it. So he was testing Postgre on an SSH connection, and he realized that it was very slow on this version. He switched back his SSH version and realized that he was connecting much faster. So that was a simple thing that actually something was wrong. And there's a nice book that one should read, The Cuckoo's Nest, or The Cuckoo's Egg. Search for its computer security book. It's a book I think written in the 80s or something. This is when they were tracking a hacker who had hacked all the way to Germany into the Lawrence Berkeley laboratories computer. And the reason it was found because there was a 10-cent mismatch between the data cycles consumed versus the actual billing that the departments did. So that led them to figure out, and it's a very interesting thing, about how you would debug something in the 80s on a Unix system and what are the sort of things we looked around. They found that the commands that person wrote were actually System 5 Unix, which meant that it was not a Berkeley person in the California region because they were all using BSD Unix. So that is, so the point why I brought in libx, yeah.
What is provenance? Like, can you explain?
Provenance means the ability to say that this thing came from there. So, so whenever you, let's say, buy a painting, the word comes actually from the art world. The provenance of the Mona Lisa, you have to prove that the Mona Lisa in the palace, whatever that is, I forget the name, is actual. Which one? Lower, yeah, thank you. So the Mona Lisa in the lower is actually the Mona Lisa that was actually painted. So how do you do that? So there are ways that the art world uses. For example, one of the things they use is they look at the cracks that are made in the oil surface. Those have a distinctive feature. So, and there was another story that somebody had actually stolen the Mona Lisa and made 6 copies, similar copies, and tried to sell it to 6 different people. So this is the point so the point is that we know how to do this, but how do we know that, what is the SBOM saying, how do we build those things on a process? And that's what I'm saying, the Cyber Resilience Act. That is a big deal in today's world. The Cyber Resiliency Act, this one, makes it so the EU has this, I need to really look at it, and this was a big thing for a lot of people. As I said, the Qualcomm folks who have to ship their processors have to be part of that. So it adds a lot of regulatory cost, which means that it also adds a lot of cost for small firms. You cannot afford to do it. So, which is a bigger problem with the regulation. So then, basically you do this stuff. So this is what we need to ask it, that who uses this library, what version and all, and that's how we are able to do it. Because if this is a CVE, then which version of the SBOM had it, what versions are impacted, what versions are not impacted, all those things. So we keep on moving. Then this is what we did. This is our talk. That's my daughter here, she's giving the talk. So our idea was that we build a simple scalable MLOps pipeline which does not depend on vendor provided stuff like Vertex and SageMaker and all of that at the time. Try to build things in-house without going to ultimate complexity. How we can do it, the idea is simple, that you basically ship the code, the data and the model together as one unit. Your model, the data, so we use something called data version control. Data version control keeps control of your data, keeps a hash, something of your data, what the data the model has been done, and the actual data is stored somewhere in an S3 bucket or something. And then when you need to pull the model, so your models the specific models become small, but then so there are multiple ways of doing it. One, we can bake the entire thing into one large Docker image, which anyway it has to happen. And then we can do a blue, green on Kubernetes, human gated, so it's vendor neutral thing. This was the talk, this is the URL of the talk. They put on YouTube, so if anybody is interested, you can look at it. So the point is that we basically said that lots of people are doing SageMaker Vertex pipelines before we exhaust OpenAI, which is convenient, but it has lock-in and opacity. So last year in summer, I was mentoring a team of students from NITIM Meenakshi Institute as part of an IEEE program, and the project that came to me was this: we want to use Google Vertex to do something. So my first question to them was, what is Google Vertex? They said it's a platform to do MLOps. I said, well, you can do Google Vertex, but by doing it, what will you really learn? You will learn that Google does it this way, but what will you? So then they said, yeah, that's right. So then we tried to build a pipeline based on completely open source tools and compare it with what Google Vertex does and how they do it. And that was also presented at LSP last year, large scale platform engineering. So the point is that how do we monitor drift? I said this was not part of this. Then the other point that I mentioned in this particular talk is that this talk is actually not for LLM models. This particular method that we said. Because LLMs are strange beasts, you cannot manage them. They need different management. This is for traditional models where you have trained the model like fraud management and all of those things. So that is where you want to be able to manage them. So we also have to understand that machine learning and AI means very, very different things, and they are different. It's a whole spectrum of stuff. If you just want to do a cat dog pattern generation, then you use CV2, which is simpler. You ideally should not be using an LLM to be able to say that, okay, give me a cat. It will work as an agent, it will actually call you a pattern match information, right? That's what it does. So you essentially be wasting a lot of tokens just trying to do that stuff. Then large models, yes. So the idea is that we do one thing well, which is the Unix instinct, which a lot of us have actually forgotten. Do one thing and do it well. Or the KISS principle, keep it simple, stupid. But sadly, we have gotten into building large monoliths. For example, and my pet peeve is the systemd thing, which tries to do everything. There was a time when you had RC scripts where you were able to read the script, you were able to understand what it did, and you could plug the stuff. But then there are advantages to it according to a lot of people. Well, that's a good point. So then we talk about AI inference. Now this was one of the interesting talks. It was a pretty technical one by Shubham Kaushik of Ampere. He basically said that AI inference is a problem that also impacts how you schedule the tasks. Normally in completely fair scheduling and all, we actually try to give everyone an X, Y, Z number, and if it preempts or somewhere, it will come. But here the new idea was that there is latency tags. So for every thread sleep you have a latency, and it's in the bar, and you can do whatever you want with the GPU, but it's not a problem that will solve it. So the algorithm that I think he was saying is that how much time has not been used by this particular thread. It was given 10 seconds, but it only went for 1 second. After that, it had to stall. So it has got a 9 second that is that the system owes it. So the owed time concept. So then, whoever has the maximum owed time is one which actually the one that whose debt should be finished off first. So that's the way we're talking about building this sort of schedule. And then Cloudflare guys said that they were actually did a LLM based kernel crash analysis. Now the interesting thing is Cloudflare has such a large number of machines, so they also have a lot of data. Because once in a while, every once in a while, some new kernel will come, something strange will happen or something, so kernel messages will happen. So now the point is that you cannot really do it in one or two people. How often have you seen a oops happen? Kernel oops. Kernel crashes. Anyone seen kernel crashes? Linux kernel crashing on the system? Nobody runs it on their desktops? Have you ever seen one? When?
I think I accidentally unmounted the GPU the driver and tried to load it and then it
crashed. Okay, good. So you have seen that. Have you seen the hot world string messages?
Yeah.
Nowadays they give you some blue screen.
Blue screen.
I don't know what to make of it.
Yeah.
I don't know. So what happened is I think I was at an issue with 7.0.10 or something with VirtualBox. So there was a dependency or something that didn't work well. So my kernel kept on crashing every time I ran a virtual machine. So actually for some period of time, I'm an arch Linux, so I bleeding edge virtually. So I actually rolled back both VirtualBox and the kernel till it was steady state and now. So that's, so now you get some blue screen that they have done like similar to what Microsoft does. Which is interesting considering that we hate Microsoft, not me, but community. But earlier on it would be a complete stack trace that would come up. Kernel loops, this happened, that happened, that happened, so what they've done is they've said that we looked at it for this production where they cut out, look at they trained LLM models on how to look at the oops messages and figure out what is happening, what is happening. So what I'm trying to say is that we need to include the OSP of how the CPUs work. So this basically is also, and this is also one of the active things that when I follow LinkedIn and all, I see lots of people are really looking at these things, how do you ensure that your CPU instances are using your GPUs effectively. There's one guy who keeps on, I forget his name, I think it's the wafer guy who works, that your GPUs are actually only effectively working at 10% capacity. So we are wasting a lot of stuff just because we are not being, either the models are not accurate or because we are hitting what is called the memory wall. How many people have heard the term memory wall? And what is it?
I have just heard about it.
Okay, what do you think it means?
Like memory stoppage and something like that.
Okay.
Facing the memory issue, like not proceeding forward.
Okay.
I think we are bound by memory bandwidth, right?
Not bandwidth per se, but more latency.
Latency.
The idea is that cache is accessible in a couple of cycles. But all the way, if you have to go down to disk, it becomes thousands of cycles. I think it could be millions also. It all depends upon the type of storage. So that's where you have to ensure that, and that is the biggest problem that we have with all of these systems, because everybody is trying to put how much can you put in cache, how much can you put in memory. Then you've got DRAM, you've got SRAM, all these things. So these have been problems since for the last, I think since the time the computers came into existence. And it's also becoming a worse thing, right? That's why you have in-memory cache like Redis and all of that. And so, but how much can you really, it all depends on how much money you have. And the point is that with today's memory crisis, it also becomes much more important how much you have. You can have terabytes of storage, but again the problem is that you can't put those terabytes of memory in a single machine possibly, in a single chassis. Which means that you have to distribute the memory across chassis, which means that you have to look at network latency and all of that. So even if you have a ton of memory, again the point that you need communicating processes, so these are the distributed systems hard problem that we are looking at again in a fresh way. Then, now this is interesting. Linus was asked, what do you think of AI stuff today? His point was that AI is think of it as a tool, like a compiler. Its job is to help me translate stuff, my thoughts into, let's say, code. They change what engineers do, not what they are designing things. So it is the engineer's judgment that needs to come in. And that is why, and that's one of the things that I still remember. I asked a niece of mine what she did, and she said that I am a C++ resource. And I said, well, I don't think you are a C++ resource. You have to stop thinking of yourself as a resource. You have to think of yourself as an engineer. Because a C++ resource will only do C++. But an engineer has to look end to end, see what things can happen. Use the best tool for the job. And that is what engineers do. This is what we are supposed to do. Okay, you can tell it to code. Is it coding right? So I'll give an example of this. So I asked Claude that I want to build a local LLM running there, but what do I need to do? It gave me, okay, you need to use Redis, you need to do this, you need to use RabbitMQ. I said, I don't need all of that. I want to run it on my laptop. All of this stuff you're telling me is okay. I said, okay, yeah, that's right. Then we use it. So that is where the thing is. It will give you, so, and again, one of the things I pointed out was that how did the AI learn? It learned from you. What if you gave it COBOL code of the 60s? How many people remember Y2K? Right? Sleepless nights trying to get. So if we had given them, if it was learning code written for the Y2K era, we would still be having the Y2K problems in the new code, right? That's the pattern. 2 digits for the year is sufficient. It doesn't really understand the context behind it. It doesn't understand the problem that is going to happen. It will keep on churning that code. So for example, I've seen that code written by Gemini is full of F strings and really long lines. And my linter, which follows the pep, whatever format is there, keeps on complaining that this is too long a line. You have got an F string without a variable to enter it. And that is what is that code? Gemini, I'm assuming, is possibly trained a lot of Google code. So, and then projects to design human scale contribution, design for AI participation. This becomes important because this is also a challenge that came up. The whole problem of which Linus Torvalds in his Mumbai Open Source Summit also talked about, that we get so many bugs based on especially security bugs found by AI and all, that it becomes difficult. So the whole Mythos problem, that Mythos has been finding bugs. Why? Because it can keep on iterating, and if you've got a machine that can keep on doing this thing all over again and make sense of it. See, you can have a machine churn out results, but how to analyze it and all, but that's what it does at machine speed. And then if you use all the techniques of fine tuning and all of that stuff, we can actually create which I think is what Mythos has done, a lot of the stuff. So you basically make a machine specifically target for that one problem and it will function well. But a human has a huge lot of cognitive load. Before we even understand what the code does, we have to read down, understand why it has been written this way, which has a lot of meaning. Because this was an interesting thing which I can come back later. And then there's an open source, they are saying protocol agent to agent transactions where you can do sell, buy and all of that stuff. And then this is that AI generated PRs have increased the human review burden. Plausibly subtly wrong contributions. So, is that really a problem? Is the PR really correct? Is the PR really solving the problem? Or is it just dumping it down? Or is it fixing this problem or creating another one down the line? So, those are the challenges that we need to look at, which AI may not become. So, AI shifts from effort from writing code to reviewing. So, the whole idea is that I tell you that I need to do this, so you do a project, it says, build me this thing, it builds you this stuff, then you look at it and you say, no, this feature is missing, this is what I need, this is how I want it to be done. So that sort of, so it's a good tool to be having and a very useful tool to have. It can do stuff that I have never done before. I've never done HTML parser before, but using AI I was able to write something that passed my LinkedIn page and gave me a lot of stuff. So we need to be doing stuff. So architecture is easy to review is the architecture that should be easy to write. We should be able to say that so that's where all those complexities that we talk about, we need to be, so whenever I look at an architecture diagram, it becomes so complex with so many lines flowing through, that we lose sense of, there's too much detail sometimes in one page. We need to be able to actually build those details slowly and understand that the cognitive load of a large complex diagram is really too high. Then, this is an interesting point. And everybody must have seen this. It has been used, this diagram has been used in everything from hormones to SSL. And this is the real problem that the open source world has been facing. Right? Everything, one thing breaks here. And that is where we really need to understand why. So this is an interesting thing. This is the guy Rob Langley. Langley.net is his website. And he also had a keynote session on how to build a minimal Unix. So I couldn't attend his conference talk because of certain issues, but I met him there and he was at the Qualcomm associate and he was one of those guys who was basically saying that Qualcomm was not doing enough. They had great product but they were not fixing it and all of that. So I just got talking to him and seems that he had a pretty good history. Toy box, busy box maintainer, he was talking about Bruce Perens and busy box, Eric S. Raymond and all how computing works. So it was an interesting thing to get into the historical side of the community building. And then, but the point is that the one useful, every layer of abstraction becomes what you don't know about. But the problem is that you really cannot understand everything. It's impossible for us to. We have to have those, and that's where the trouble comes with that when at 3 a.m. that this might be an oversimplification because you cannot say that you remove the OS because you can't understand this. But the idea is that if you are building something and something is breaking, you need to understand why it is breaking or what it is, especially the thing parts that one builds. One has to assume that the OS provides those services and anything that is happening below it. But We need to be able to understand, debug stuff at the OS layer, understand all the stuff that happens to be able to understand that stuff. Then this is what Qualcomm, Rashmi Chitratar was the Qualcomm Senior Director of Qualcomm at the Open Source Development Office. And her point was that they basically moved their structure for Qualcomm boards to be able for people to develop it from being in closed source and everything, and they providing you the entire, what do you call it, board package, BSP board support package, to actually bring it out into the open. And there, her point was that the government, and it was very important when I asked them why they did that, how they were able to get success, was the point that they found a person who was willing to sponsor them. So they need to build in all the practices. There should be somebody who's willing to sponsor the fact that there will be open people contributing to it, they govern it. Then legal review is a big thing, and again this ties back to the CRA thing, the Cyber Resiliency Act. Do you conform with it? Do you conform with the DPDP? Do you conform with it? So all that stuff. Are your licenses correct? Are you pulling in stuff that is not legally permissible? If you are following the LGPL or GPL, are you giving everything back? Or are you holding things back? What can you hold back legally? Can you ship? So all that, and that is a huge angle. Then community trust takes a lot of time. But then again, as you mentioned, the libXZ thing, you build trust, somebody hands you the code, and then you do incorporate malicious code. So this is a big problem about the trust factor. And I think that is a problem, that's a social problem, it's not really a technological problem. How do we ensure that the people, and this is also what Linus was saying in this Mumbai open source talk, that the reason I can review all these patch requests and all of these that come fast and all is because I trust the people who do it. I may not trust the organization, but I trust the people because I'm working with them. So the idea is that everybody should be trustworthy. We all assume in the open source world that we trust, but well, they are state actors also, or non-state actors also. So then this was an interesting thing that I saw there. There were just two booths that I looked at. One is this coder.com. They said that there was this development platform which can be self-hosted, which is why I liked it. It works. And this was an interesting thing. I tried using it. Once I found it, the Kilo is, I think, Claude Code and the other one that is there, right? That coding platform that is used a lot. Cursor. So, but Kilo actually has a lot of open free models of it, which you can select, and you can use your own tokens also to do it. You can use your own subscription also. They said they don't do it, they don't charge you anything additional to it, passed through completely. So this is, so their open models were also, free models were also reasonably good at coding as whatever testing I did. So it's an interesting tool to look at. So this is the whole idea of the talk, the takeaways. Is it a minimal defect free? Can we answer that? Which services have this MLU? So can we debug it fast? So inference performance. So these are the new things that are happening. Real time is coming on mainline kernels, which was a big problem that we didn't have it. Then the generic base images are becoming requests, the registry economics, burnout of maintainers. So how long will, which again ties back to the whole thing that there is one guy who's maintaining everything. Can we really, if tomorrow he comes and flows under the bus, then what happens? And there are projects like that. The NTP project, for example, the network line protocol, complex piece of software. There is only, I think, one or two maintainer people really don't know how it works. As OpenSSL has this problem. So how do we solve that problem? How do you do it? Because everybody really wants to rewrite everything in Rust, right? Today.
Yeah. But
then the C layer matters. Then this is an interesting thing. LLVM and CLAN are displacing GCC in some two genes. And this was an interesting point that I asked that Linux kernel, anybody built using LLVM? Because it seems the Linux kernel still have a lot of dependencies on specific GCC extensions that don't allow it to be built by LLVM. So I'm not sure what's the current status, but that was one of the things. So this is what it is. So this is what the topic is, that from scratch. It's not just a Docker file line, it's because you can choose it. And understanding the why is often more difficult than the how. And this is what I got from Rob Landley. When I was talking to Rob Landley, he said, I've got the talk day after tomorrow. I'm still undecided about whether to tell people how to do these things or tell them why to do it. I said, he said, telling people the why to do it is actually a 3-hour long talk. But how to do it is what I can tell them within an hour because I can show them. And that becomes an important thing. Why are we making these decisions? What is the backbone of these decisions? How do we justify it? How do we ensure? And that is where the human judgment comes in. And why you are building something from scratch? Why are you really building something which is so minimal? I mean, and this is, and look over all those that you see that there was this interesting YouTube video where these people were saying that the earlier computers actually used to get from your boot time to the terminal screen much faster than the new ones do.
Yeah.
Why? I don't know. Why do you need 2 GB OS on your phone? Yeah, right? Because we need all those services that allow the, so that's one angle to it.
For example, Facebook services come installed even if you don't install Facebook. Why?
And the point is that if you try to build your own Android, which is supposedly open source, none of your banking applications.
Yeah, the major issue.
Yes. So,
Enabling debug disables them.
so I have this thing called CubeACR connector, which is basically an accessibility tool which I tried to do to record WhatsApp calls, but it doesn't do it correctly. It only records my voice, doesn't record the other one. But my banking app actually tells me that you have enabled this stuff, so I will not run. Or there are lots of them, if you are connected to a open Wi-Fi, they will refuse to run. ठीक है यार, हमको भी थोड़ी अकल है.
But banking apps also, why do they need so much permissions? We don't know. Like on net banking they don't, but on phone they will. Why? Nobody.
One of the things is they need SMS permission to be able to send that. Then they need the call management thing so that they can tell you are on a call, do not send your OTP to anyone. I mean, it's ridiculous.
I think now there is one called Graphene OS, which is coming, which is like, it's an open source platform for like Android like OS layer where it's like completely shut down. Like it doesn't give you like access to anything. It's very private focused, everything. And I think Motorola is doing collaboration with them to bring it to their own phones.
But then Dean will not work now.
Yeah. So I think that's the problem where if some vendor is willing to do, like Motorola has.
But the point is, which vendor is willing to do, which vendor is willing to say no to Google that we will not accept your Play Store conditions.
Yeah.
Right? The big problem is not that. The big problem is not technological. It's the problem that it will not be Google certified anymore. If it doesn't have Google Play Store services, it won't be Google certified. If it won't be Google certified, then nobody will use it. Your apps will not work. So we are logged into a it's a monopoly. It's actually a duopoly. But one part of duopoly is so expensive that you can't get into it. So this is what it is. Connect with me on LinkedIn. So now I think we have some time for questions. We have got 11 minutes for questions actually.
As we have seen 3 decades of change in the industry, what are your thoughts like on the AI thing when people say that in 10 years down the line, people would not know the internet.
Is the other mic?
Actually, that's true.
But we
Because we have become so attuned to the fact that AI is writing it. So interestingly, there's this girl at Western Digital, Matangi, at LSP 2 weeks back, she gave an interesting talk on model collapse sort of a thing. The idea being that models are learning from AI generated data. And that is where when you have the provenance, and that's where it becomes important. Where did the training data come from? Was it a book that was published in 2000, or was it some made up stuff that ChatGPT created? Right? And that's where so as I said, so Google says 75% of their code is being written by AI. And then that code is being used to generate, to train Gemini. So you will actually be going down a rabbit hole.
So you learn from good things, generate slop, then learn from slop, then become slop.
Garbage in, garbage out. That's exactly the point. That's where the human oversight becomes much more important. Is it even doing the right thing? Is it even referencing those things? That's why we have all this whole idea of and the bigger problem that you have with LLMs, not AI in general, is that they are completely non-deterministic.
Yes.
The answer it will give you is very different from the answer it will give him for the same line of code. It knows you like Python, so it will give you Python code. If you use Go, it will give you Go code. Somebody else, it will give him basic COBOL code. And the point is, second time you ask it, will write you something completely different. And that is where it comes back, that's an interesting point. So, I have a sister-in-law, she works at KPMG risk management. She was asking me that I need to be able to identify risks models. While going this conversation, we realized that